Welcome, welcome. I appreciate it. And another lovely spring day out there. Um, as I may have mentioned on some of the announcements, I'm feeling pretty crummy because I got my second dose of COVID and for the vaccine. And uh, the good news is my immune system is working. The bad news is I feel like crap. I will feel better tomorrow. But anyway, we'll still do this. What we're doing in class is the history of the internet, and that will wrap up the 20th century. And then after that, we will do next week a review and a test and maybe a couple of things like that, but we're done. This will be the last test. No more tests, no final exam. The tests are enough. Might do one more essay to boost grades, but you're all doing pretty good in this class. So I'm real pleased with that. It has certainly been a journey. Anyway, we do have, and I did post one more extra credit question just before class that's available. That's due Friday if you want to do it. It is one credit of, one question, extra credit if you get it right, deduction if you don't get it right, no difference at all if you don't do it at all, purely optional. Anyway, the story of the internet. Obviously keeps us all connected all the time. Thomas Friedman wrote a book called The World is Flat. Meaning for the internet, actually, that means all connected over. I can, for example, I can look up Facebook and look up my cousin Vital. Here he is in Cyrillic. This is my cousin Vital Ziblik in Belarus, Russia, and he is a radio broadcaster. It must be genetic. I can drop him a note and say, "Здравствуйте, Vitaly," which means, "Hi, Vital." But yeah, the world's flat. He's on the other side of the world, and I can call him up anytime. That's what we mean by the world is flat. Obviously, it disrupts other media. Everything, streaming, radio, it's all right here. Unreliable. We have trouble with connections, but the real weird thing is that we have trouble with truth. I will walk into the store and someone will talk crazy stuff. I had an argument with somebody who said the Hadron Collider in Switzerland is a direct link to Satan himself. All right, I never heard of such a thing. You have all sorts of stuff out there. The internet, all other media is on the internet, radio, TV, movies these days, because of COVID, they've all gone to streaming to online. And therefore, the internet is ubiquitous. Being the history.
The internet is the defining technology of our time, an historic revolution in communications for the human race that is changing the world.
Well, the internet is the next big thing. It is on a par with the wheel and fire and language and the printing press.
The internet enables millions of people with personal computers to communicate and connect. It's email.
You've got mail.
It's news groups and chat rooms. It's also the world's largest marketplace and shopping mall. And it's a link to websites the world over with information for every aspect of life and even the life after.
This is, in fact, the telecommunications.
Yeah, we know that. But this is the best history documentary I could find. And the History Channel keeps moving it because of copyright issues. They don't want people to use this for commercial purposes, so I have to keep trying to find it, and they keep blocking it. Now, am I doing anything wrong? No, because it's for a class and it's legal, but they move it all the time.
This is the age of the internet, a global network of computer-based communication. At the turn of the 21st century, millions of people around the world are now online every day to exchange messages, conduct business, meet people, and find information. Free from the limits of time.
Yes, we know what it does.
Telephone, with the automobile, or with the printing press. This is an absolutely incredible communications tool, and it gives us instant access to things happening everywhere.
In scope, more email is exchanged on the internet today than first-class letters delivered by the US Post Office. In financial importance, the internet generated $301 billion in business and was responsible for 1/3 of the total US economic growth in 1998. It is a key component of our culture and civilization, and yet no one really controls it.
Things that matter the most usually don't have anybody in charge.
The seminal idea behind the internet was envisioned by a psychologist named J.C.R. Licklider, a professor at the Massachusetts Institute of Technology in the 1950s.
Licklider's vision was that computers would allow you to communicate better, and that would allow you to connect all the computers together so that they might be more useful in the sharing of information among people.
Computer communication was a flight of imagination far beyond anything at the movies. Computers were portrayed as sci-fi props like electronic brains, alongside robots, ray guns, and flying saucers. In fact, the idea of a worldwide communications network of computers was far more imaginative than anything Hollywood came up with. After all, the first computers were monstrously large and expensive devices that were never intended to communicate.
All the computers were as big as a room. You were lucky to have one in a city, or maybe one on a campus, or if you were lucky, one in a room.
They could have remained standalone computing machines for a long time, but a frightening display of Soviet scientific superiority during the Cold War spurred them into teamwork. In October 1957, the Soviet Union launched Sputnik. To catch up and hopefully surpass the Soviets in space technology, President Eisenhower created a bureau at the Defense Department called ARPA, the Advanced Research Projects Agency. It was in charge of the space program, which then included computer science. But when the space program got its own agency, NASA, computer research fell into relative obscurity. America turned its attention to conquering the stars and beating the Russians in space.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
While America gave birth to a space program that grew from a crawl to a run by presidential edict, computer communication was in the embryonic stage, but it was making progress. At MIT, a graduate student named Leonard Kleinrock began applying queuing theory to data transmission.
Queuing theory
Yeah, we don't really
is a
have to go
fantastic.
into a lot of the more technical things, but the important thing is the internet was invented by the US government because of the Cold War. We were afraid that the Russians were going to nuke Washington or New York, or LA or Chicago. So if we had a communications network that could work when other cities were nuked, then we could function militarily and governmentally. That's the point. Other kinds of communication were all about money. Telegraph and radio, it's all about advertising, all about money. It's about people who wanted to make money. It's a business. The internet was never meant to be a business, which is one of the reasons why it's so weird.
Tool for evaluating computer and communication systems. You know, a queue is a very simple structure. It simply is
Just waiting people in line, that's all fine. Okay, now here's
Paul Baran was hired to see if one could be built.
We started off by playing with fishnet type networks so that if you chop it up, there's still a path through the network. Now, the problem was we didn't know how to do that. So came up with the notion of what we call the hot potato routing, sort of a demonstration that it's doable so the traffic could find its way through the network. But to do that, we had to chop the data up in little pieces.
Hot potato routing meant a message transiting a network got to where it was going, even if part of the network was destroyed.
see,
But how? Baran was inspired by a previous study of mice in a maze.
Claude Shannon in 1952 built a machine that modeled a mouse finding its way through a maze. And said, well, if we could model a mouse going.
and that's how your information gets to where it's going. It's just kind of winding its way around. So if a node goes down, it'll still get to where it's going.
Your favorite drive-in?
Oh, I think you want to make mine a ham sandwich and coffee.
But as the decade wore on, new ideas were reshaping America. For some, civil rights was the cause, for stuffing the Vietnam War. For others, it was landing on the moon.
212. Okay, engine stop. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, you got a bunch of guys about to turn blue.
But in the world of computers, the new big idea was something called time sharing.
The old computers had been big machines that you punched cards and you submitted the cards in decks, and the next day you got the answers. But in '69, time sharing was happening, where you would actually sit at a terminal and you would type.
Yeah. Have these little interactions. We have networks. You don't just put something in and it comes out.
Link them in a chain. But this design had a flaw.
If you tried to interconnect the large computers directly, then each of those large computers would have to figure out how to work with each of the other large computers.
Yeah, and it wouldn't really network. So
'68 was a medieval time of communication technology. Typewriters, not word processors, pounded out letters. Most telephones used rotary dials. Black and white television was as common as color. The height of high tech was the lunar module, which had less computing power than today's personal computer. 1968 also was the year Larry Roberts sought out the engineers to build the Advanced Research Projects Agency's computer network, the ARPANET, the acorn that would grow to become the mighty internet. It was going to be based on special purpose mini computers called interface message processors, or IMPs.
yeah, and so you would be sending little messages from different universities.
PM36075 at the University of California at Santa Barbara, and a PDP-10 at the University of Utah. Roberts asked 140 companies, including AT&T and IBM, to bid on the project. But the giants of communication and computers refused. They said it wouldn't work.
No, they didn't.
The scientists at the university went to the phone company. They went to IBM and said, we've got this internet thing. And they said, why should we have that when we have the phone? Go away.
didn't think it would work. They didn't see that it was very important or mainstream. I mean, after all, communications, well, we've got our own communication systems here at IBM, and AT&T does the telephone system. What else do we need? What's your problem?
So the telecom guys would say, little boy, go away. You represent no revenue to us.
Yeah, they told him, yeah, go away.
But they were willing to try. Frank Hart headed the BBN team.
Well, we had to, first of all, figure out if we knew how to do it. I think
Okay, so they're trying to put together this network at universities. Go ahead a little bit. Okay.
Computer to it.
The thrill was connecting things together. You know, there's action at a distance, how, you know, you can wiggle something here and it moves over there. So I was able to form packets of bits and send them. And over the phone, the guy in California would say, I got it.
Good, send the messages. Ooh. Okay, now you're starting to send
Mail.
messages. Look what happens next.
I was actually working on a mail program, but it was programmed for a single computer so that you could send messages from yourself to another user on the same time sharing computer. And I had written a couple of programs to transfer files, and it occurred to me that since the mailbox that I was sending these messages to was nothing more than a file, I could send that file across the network instead of keeping it within the same machine. And so I put two programs together, modified the code a little bit, and the first email program was created.
Tomlinson did more than just write the code for email. In a keystroke, he gave the world a new icon for the information age, the @ sign.
The @ was the most obvious choice because we're talking about a user who was at some.
He invented email and the @ sign. He just died this year. But yeah, I mean, and it wasn't like it was planned. He's sending messages to his buds in California when he's in New York or Boston, and they're just messing around. There was no money in any of this. There was no incentive. And that's still a problem today, is making money on the internet. Why pay for something that costs money when you could get crazy crap for free?
Computer, and it just made sense.
Ironically, what would become one of the most popular applications on the internet was a program Tomlinson wrote on his own time.
It seemed like a neat idea. Nobody was clamoring for email. I mean, there's nobody, our sponsor, Department of Defense, didn't say anything about wanting email. My boss didn't say anything about email. But in fact, nobody said anything about email because the term wasn't coined until several years later. But it just seemed like an interesting thing to do with a computer and a network. And so I just did it.
So then electronic mail became the completely unanticipated killer app, as we say, for the ARPANET. We went from remote login, file transfer, electronic mail in a year flat or 2.
Yeah, and I keep calling it the killer app too. It's not the network, it's what you put on it. It's not the telegraph, it's the Morse code that you put on it. It's the apps again and again and again, not the hardware.
2 years flat, and then it stayed that way for 20 years.
In October 1972, ARPA turned science fiction into science fact when it demonstrated the computer network in Washington, D.C. But unlike flying saucers, this idea really did take over the world. The telephone, television, radio, and postal systems are essential communication infrastructures for life as we know it. But as the world enters a new millennium, it appears as if the internet, begun in 1969 as an experimental computer network, is gradually absorbing many of their functions.
Yes.
The internet can do that because it was built with an open architecture. It's a superhighway with plenty of on-ramps, lanes, and no traffic restrictions. It handles whatever comes down the road. This generality of purpose is the brilliance of its design.
We were very conscious that we were opening up new territory, and that rather than pick very limited applications, that we ought to lay a foundation that was as broad and open-ended as possible.
inclusion guided the network's development. Anyone could contribute ideas about its use and how to improve it. Ideas were offered as requests for comments, so everyone would feel free to discuss and criticize them.
I wanted to emphasize the point that we were not making assertions or edicts, but that we were trying to create a dialogue, that we were putting forth ideas, and that it was supposed to engender responses. And so we made the simplest possible rules. Anybody could write anything they want, that it had no status, that it got whatever credibility it got from its content, not from the fact that it had been blessed by somebody.
There's a kind of internet culture which grew out of the academic community. What you find is that there's a tradition of sharing of knowledge, and people will add to it. They will find mistakes and bugs and they'll fix them. They'll tell you about them and everybody else. The rate of
See, what gets to me, and I'll be honest about this, is that you have these scientists who want to share information, good information, and they wanted to just make the world a better place. Did any of these people think of sending pictures of their junk to other people? Probably not. They could not envision some of the crap that has gone on.
evolution. The rate at which the new functionality can be added is very higher, much higher, simply because so many people are contributing to it.
By 1972, the ARPANET had fewer than 25 sites online, yet more were coming. What sparked the increase was the first International Conference on Computers and Communication, sponsored by ARPA as a coming out party for its network. Bob Metcalfe, fresh from MIT and Harvard, was in charge of compiling a list of just what the network could do.
So all I did was contact all the people who had computers on the ARPANET, and there weren't very many, like 19 or 23 or some number, and said, do you have something interesting that's going on at your host that you'd like other people to access over the net?
Metcalfe could only find a few esoteric uses for the fledgling network, but at this early stage, that was enough for an impressive demonstration.
By the time of this demo, I could find 19, imagine that, 19 different things that you could do on the net. And they had a program that pretended to be a psychotic. They had games that you could play. They had demonstrations of symbolic manipulation of mathematical formulas. They had more technical things like remote job entry for submitting jobs from one computer to the next and getting the results back.
But demonstrations sometimes go wrong, and at the wrong time.
Well, imagine a graduate student, big red beard. I put together this book, and in walks 10 AT&T executives, all in pinstripe suits. And they needed someone to give them a tour of the ARPANET. So I was the natural choice, having done the book. So they gave me these 10 executives, and I started giving them the tour. And right in the middle of the tour, the ARPANET, for the only time during the 2 or 3 days of the demonstration, the net crashed, the computer, the IMP crashed, and the demo froze.
Yep. The phone company people come in and he's there like, we have the internet. And it crashed. It didn't work.
There was this poor graduate student having worked on this for
Anyway.
National Science Foundation made being on their network a requisite for receiving grant money. Soon, other networks emerged. There were LANs, or local area networks, to link computers throughout offices, and WANs, or wide area networks, to link computers across buildings or campuses. But each new network was like a foreign country speaking its own language. Could disparate networks be interconnected to make an internet work? In 1973, Bent Cerf and Bob Kahn teamed up to develop a set of rules or procedures known as the TCP/IP protocol.
Yep.
That if followed by different computer networks,
That all the computers in the world have the same language. And it's these guys who made it up.
was adopted as the universal standard, marking a milestone in the development of the internet.
And did they patent it? Nope. Did they make money off of it? Nope. They just said, go ahead and use it.
A common network of interconnected networks.
If we have enough in common, if we hold enough in common, then we can communicate. If we don't hold enough in common, it's much harder. So in fact, the reason that the network works at all is that we have worked very hard to create all this commonality so that we share enough knowledge to make it possible to convey information to each other.
The ARPANET was developed as a tool for defense research and restricted to select universities and think tanks engaged in government projects, not individuals or businesses. For this reason, private networks like Prodigy, CompuServe, and what came to be called America Online started to spring up where individuals could join in.
Yeah, and those what we were called walled gardens. Rather than join the network, they use the phone. You hook up your own computer through their program, through the phone, through dial-up, and you can only talk to other Prodigy or AOL users. It was a closed network.
Still, the internet had not reached Main Street, USA, but a major milestone in its young life was about to see all that change. Unlike technological breakthroughs that swelled the use of computer networks, this milestone was political. It would unleash the full power of free enterprise and American ingenuity and bring a worldwide communications network into the home and office. The internet grew by the fate and fortune of new technologies. Among them were breakthroughs in electronics that brought mainframe computer power down to the size and cost of a desktop PC. The silicon chip, the high-speed modem, and the computer mouse are as significant in shaping the use of the internet as the first IM. However, one of the internet's major milestones was achieved not by technology, but by an act of Congress. On June 9th, 1992, Congress passed a bill taking the internet out of the exclusive hands of government and into the public. The following November, President Bush signed it into law. The internet had crossed the Rubicon.
The government, in particular National Science Foundation, which have been investing in research in the ARPANET. And
They said it's free, go ahead, use it, figure it out, see ya. They used to say that Tennessee's own Al Gore claimed he invented the internet. He wrote the legislation that made it free for everybody. So they just gave you this network, whereas the phone company owned the wires. So they gave you all of this and said, have fun. The problem is nobody was in charge. And that's still a problem. Whereas in broadcast, you have the FCC. We don't have that on the internet.
then the internet began to get the idea that maybe this should be turned loose. This technology should be turned loose into the open world for commercial use, for whatever use. And that unleashed a lot of
including harassment and porn. And none of these people saw that one coming.
Commercial energy and competition and progress.
By allowing free enterprise and individuals access to the internet, the seeds were planted that would flourish into many new and previously unimagined uses. But the dream of easily sharing information among computers was thwarted by the complexity of finding it. It was like having the Library of Congress at your disposal, but being unable to gather what was written on a desired topic without tedious and often discouraging hunts. Under 1980s technology, it was difficult to research a topic without being a computer wizard. Around the same time that Congress was opening the internet to more people, a physicist named Tim Berners-Lee at the CERN Research Institute in Switzerland created an easier way.
CERN was a microcosm of the rest of the world in that it was global. A lot of people reporting to different institutes, trying to solve problems together. But unlike the rest of the world, most people had workstations on their desks.
Berners-Lee developed the software to more easily follow threads of knowledge within the information stored throughout the internet.
computers are good at storing information in trees, in matrices. They've been programmed to work like that. They hadn't really been programmed to store information in random associations, so that when you smell a particular type of coffee and it takes you back to the coffee house where you first smelled it, that is the sort of thing a brain can store. That's not the sort of thing that computers were programmed to store.
By using a computer mouse to click on a word or phrase linked across the internet, one could instantaneously follow a link from site to site around the web in pursuit of a topic. The crisscrossing of these myriad threads across the globe reminded him of a web. So he named his invention the World Wide Web.
The next thing you know, it started growing on itself. It went from just Tim in his little computer in Switzerland to a worldwide phenomenon carrying billions, going on trillions of dollars of commerce. It's just an incredible story. And completely unexpected. None of the geniuses who designed the ARPANET in the beginning had any idea that anything like that would happen.
Even though the World Wide Web made it easier to follow threads of information, it was not terribly user-friendly at first. But it gave the internet a revolutionary new capability beyond file transfers and email. Still, in 1992, there were only 50 web pages on the internet. If the World Wide Web made the internet more accessible, another development rocketed it to near instantaneous acceptance by people far and wide. This was a very user-friendly software used to browse the World Wide Web. It was developed in 1993 at the University of Illinois by a 22-year-old student named Marc Andreessen.
It was called Mosaic and later commercialized.
Yeah, and he invented the web browser. The other guys invented the web and had HTML so they can all talk to each other. Marc Andreessen at 22 invented the Mosaic browser, and he sold it, I think, to IBM and then Google. And he's one of the richest people in the universe in his 20s, because unlike all of these nice scientists earlier, Andreessen patented his program
By Netscape that enabled access to the World Wide Web and therefore made it a lot easier for people to get access to content.
Marc Andreessen's browser turned the internet into a graphically rich world, the very signature of today's internet. It was able to display text, use scroll bars, jump around the web at the click of a mouse. In short, it was the essence of user-friendly. It wasn't the first or the last browser, but it was a breakthrough application.
In this case, a short video.
The killer app that brought the fire of the internet and web to humankind. In 1993, after Andreessen's browser hit, the web grew by 341,000.
1992, it goes public. 1993, you have the invention of the web browser. Boom. Mind and computers blown.
%. By the late 90s, the internet had grown in simplicity of use, complexity of performance, and multiplicity of information. It now had completely redefined the use of the personal computer. What was once an in-the-house word processor and spreadsheet calculator was, by the end of the 20th century, a way to get out of the house without leaving it. A way to go online with the world.
Well, the only reason you have a television is because of the network. And pretty soon that will be true of computers, that the only reason you have a computer is to be on the network, not to do word processing and spreadsheets. Those are incidental.
At the start of the 21st century, the internet is turning everything from business to games to dating into a series of keystrokes and mouse clicks. Everything the free enterprise system can put on sale is going online. Web pages can even turn one person's interest, no matter how unique, into a source of information for others. This online community, called netizens, now communicates and connects around the globe, unfettered by boundaries and borders, all because of this great communications infrastructure that was built like a great cathedral, one brick at a time.
All well and good with well-intentioned people who weren't in it for the money. Unfortunately, things got a little messy and we will get to the modern era next time and finish up the class. I appreciate your presence and your patience, and I will see you next time. Any questions on anything coming up? We'll do a review and test next week. All right, we'll talk at you then.